Okay, so here's the solution for the 2017 higher level question 1, simple harmonic motion. Okay, student time was following data was recorded. Why did the student use a small angle? The small angle is required for true simple harmonic motion. With larger angles, its air resistance affects the experiment. Okay, we just want it swinging over and back because of gravity, but nothing else really affecting it. How did the student ensure that the pendulum was suspended for a fixed point? Oh, okay, that's fine. That's just using a piece of cork with a slit cut into it. Okay, between which points was the pendulum measured? From the bottom of the cork to the middle of the bob. Part 4. Which t value is most accurate, and explain your answer. Which t value is the most accurate, and explain your answer. So go up and look at the t values. Okay, we're going to go with the longest value, the t value of so the t value of 77.3 is the most accurate because due to its length, it has the smallest percentage error. Okay, so the longer you get, it's easier to get it to go through the tiny angle, and any error that you get with parallax should be minimized because it's a small little percentage. Like if you're, let's say that you're always 0.1 of a millimeter wrong, then 0.1 of a millimeter compared to 90 centimeters is better than 0.1 of a millimeter compared to 20 centimeters. Okay. All right. Draw a suitable graph between the length of the pendulum and its period. Okay, I'm not going to draw the full graph, but what I will draw is the axes. It's L in seconds over t squared. Oh, I'm an idiot. L in meters versus t in seconds squared. Okay. As always, look, you plot your points up along, you put your circles around them to represent your percentage error, and then you're looking for the best straight line that goes as close to them as possible that goes through the center. Okay. The marks you get are for labeling your axes and plotting your points correctly. So look, just being consistent with your units going across on the axes and up on the axes, making sure it's the same gap each time, and then fitting your straight line as best possible, like as close as possible to as many of the points as possible, going through it. Okay, using your graph to calculate the acceleration due to gravity. Okay, so you pick 2 points that are on your line, let's say there and there. Okay, find the coordinates of those. Look, you're trying to help yourself, try find points that are close or exactly on if possible, you know, major markers on the line. And then the formula is L is equal to, can I do this? 1 over 4 pi squared t squared, no, 1 over 4 pi g squared by t squared. Isn't that it? No, g times t squared. 1 over 4 pi t squared. Oh, I took a risk and I've messed up. Let's check the marking scheme. Substitute into the formula, t squared is equal to 4 pi squared L over g. Yeah, that was right. Okay, so what we want essentially is, the way I've drawn my graph, I want L over t squared. So L over t squared is 4 pi squared over g. Okay, so whatever you get for your slope, oh, I should have done t squared over L. Anyway, it doesn't matter. Whatever you get for your slope, you are going to, in my case,